Hello, my name is Aiden Rabzadeh, and this is the tiny clock I2C. Here are my parts on screen. First, I'll show you the circuit working. Here, as you can see, the final result as produced. It says scanning our I2C bus, and it finds two devices at these two addresses. It says how many devices are on the bus, and finally it reports the temperature, and this is from the TC74 temperature sensor right here. So if I cover this with my hand, the temperature is going up 28 degrees, 30 degrees. There you go. The tiny clock I2C uses wired communication to scan all the addresses of the I2C bus, report back the addresses which have a device connected, and read the data from the TC74 temperature sensor on the bus. In the circuit, these top two rails are the SDA and SCL lines, and these are just power and ground. By using only 2 pins on a microcontroller, for the Arduino Nano, this is A4 and A5. It is possible to monitor 124 devices simultaneously. Every device has a hard-coded address on its datasheet to identify it when using an I2C bus. And they are all active low, so pull-up resistors are required to make sure they remain high normally. This data signal is transferred in a series of bite-sized packages. The start condition occurs when SDA drops low while SCL is high. Now the clock cycle begins, and each bit of data is transferred during each clock pulse, from the most significant bit to the least significant. After the start condition, the first byte indicates the address of the slave device to which the data is sent. The next bit, which follows each byte, is acknowledged. Control of the SDA line is given to the slave device, and if the SDA line is pulled down, this indicates that the device has received the previous byte. If true, a byte indicating the internal register address of the device is sent, followed by another ACK bit, after which comes the byte of the data being sent, then an ACK and stop condition. The stop condition occurs when SDA goes high while SCL is low. Now I'll do an overview of my code. First, we include the wire library, and then we create all of our constants and variables. In the setup, we begin the wire library, initiate the serial monitor, and wait until serial is ready before continuing. In the loop, this is where it all happens. First, we reset the device count, and we print scanning our I2C bus. After this, we have a for loop which scans addresses 1 to 127 for devices, and in each iteration, it's going to start a wire conversation to the specific address. Then it will end the conversation and get the return. If a device is found, is going to print out its address. This is because the end transmission function will return a 0 if a device is communicated with. So if the result is 0, we're going to print I2C device found at address hex, and then we're going to make sure that the hex address is 2 bits by adding a leading 0 if it's less than 16. And then if not, we're just going to print the address in hexadecimal and add 1 to the device count. After that goes through all of its iterations, we begin the transmission to the temperature sensor and request 1 byte of data from the TC74. After this, we set the data from the TC74 to a variable called temperature and print the number of devices found on the bus. After this, we print the temperature received by the TC74. After all this is done, we delay it by 5 seconds to allow for hot swapping. Thanks so much for listening, and I hope you learned something about the I2C bus and how to use the wire library to read devices on the bus.